For experiment 1, molar mass of a solid, some of the data that you would have collected is the mass of the test tube, so you might have zeroed some of that out or tiered it in order to get the mass of just the tube. Then you went ahead and did the experiment and extrapolated the freezing point. So the freezing point of just cyclohexane, this is a former student's set of data, was 4.86 degrees Celsius. Then you would have taken the freezing point with the solute. This is the mass of the test tube plus cyclohexane, and then the mass of cyclohexane then is the mass of the combined minus the mass of the tube, so we get 9.221 grams, or that will be 9.221 times 10 to the negative 3 kilograms. All right, and I put it in kilograms because in the formula later you'll need that in kilograms. So your mass of unknown that you would have weighed out is 0.110 grams. And then the extrapolated freezing point after doing that freezing point was 4.430. And then the mass of the unknown for the second trial there you can see, and the freezing point, and then the mass of the third and the freezing point is there. So with each of these trials, the freezing point decreased, so that's good. For the calculations, other calculations in part E, you want to calculate the TF. So the change in the freezing point is the freezing point of the cyclohexane minus that of solution 1. So the 4.86, which was here for me, 4.86 minus the first one. So after I calculate that, I would get here 0.43 degrees Celsius. This should be orange. And then it would be for this one, again, it's just 4.86 minus the 2.66. This is 2.20. And then for trial 3, it will be 3.01 degrees Celsius. So that's how you would find the TF. For number 2, when you're calculating the moles, you are given the formula of, or the KF of cyclohexane is 20 degrees Celsius per kilogram. And that's in the lab manual in the table for cyclohexane. For trial 1, delta TF equals the KF times molality. So we can find the number of moles using molality. If you remember that molality equals moles of solvent per kilogram of solvent. So we have the delta TF, which we just calculated, the KF, which is here, and then we have to figure out the moles of solvent, and we know the value of the kilograms of solvent. So we can just rearrange. So we have delta TF times kilograms of solvent over KF. So again, you're just multiplying this over this side and dividing all of that by KF to get the moles of solute. So for trial 1, I have that here. So the 0.43, that just came from down here. This 0.43 times the 9.221, that was the kilograms of solvent here, of the cyclohexane, and divided by the 20, which is the constant, which was up here. So that gives me a value of 1.98 times 10 to the negative 4th moles. For the second, again, you just plug in your other values. You just plug in your 2.2 degrees Celsius change times the same mass of cyclohexane, because you didn't add any more cyclohexane. This one comes out to be 1.01 times 10 to the negative 3rd moles. And again, all of these units cancel out, so degrees Celsius cancels, kilograms cancels, and you're left with moles. For trial 3, I get 1.39 times 10 to the negative 3rd. And then for number 3, you're asked to determine the molar mass. So if you remember, moles of something equals the grams of that something multiplied by the 1 mole over the molar mass. So we can rearrange to get the molar mass of A equals grams of A over N moles of A. So this works for us because you're trying to determine molar mass. We just calculated the number of moles, and we have grams from the beginning of the experiment that you weighed out. So for the trial 1, you have the molar mass of unknown equals 0.110 grams. That was from what you weighed out initially, divided by the number of moles there. And that will equal, for this one, which is a very interesting number, 556 when I round, and that's units is grams per mole. So again, this is student data, so this is not going to be perfect, and that seems like a very high mass. And theoretically, all of these molar masses that you calculate will be similar to each other. That's theoretically. So molar mass of an unknown, this is for the second trial. So you added another 0.1 grams, so you want to add that in addition to the 0.11 that was originally here. And again, this is the moles that you calculated in the last problem. So this one comes out to 231 grams per mole. And that one seems more reasonable. And then this one here, again, you have the 3 different masses. You want to include all of those times the number of moles. So you get 242 grams per mole here. So these two aren't too bad from each other anyways. That one is quite high, but you'll take the average of all of them to fill out the table. So that's how you do the calculations for experiment 1.